So we'll do binomial theorem today. Okay, so this binomial theorem, for example, we have studied about, let us say, the number a plus b whole square, a minus b whole square, and all this. Okay, so we know a plus b, a square plus 2ab plus b square. Okay, then a square minus 2ab plus b square, or whatever. So these we have done. Okay, so. mm, so when we are like say uh, we are doing say 98 square. So it is not that easy to find out 98 square because it's a big number. So it is not that easy. So what we do is like 100 minus 2 whole square we do. Okay. So this formula we can apply, and 100 is easy to find and 2 is easy to find. You can find out. Okay. Similarly, say 999 square. Okay. 999 square is equal to 1000 minus 1 whole square. Okay, so this also why we are taking, because 1001 we can easily do. 999 is not that easy. Okay. But this up to square or up to cube, even cube, you know, a plus b whole cube is equal to, like say, a cube plus 3a square b plus 3ab square plus b cube. So this also easy to do. But beyond 3, like a plus b to the power 4, a plus b to the power 8, 7, it's not that easy to remember. It is not that easy. Okay. So so let us say a plus b to the power n. Okay, so there should be a formula for this. Okay, so this thing is being addressed by binomial theorem. Okay, so the coefficients. Okay, so let us say a plus b to the power 0. Okay, a2 plus b to the power 0 is nothing but your anything to the power 0 is 1. Okay, it's a constant, right?
Yeah.
Okay, so then a plus b to the power 1, okay, is a plus b, right? Then a plus b to the power 2 is equal to a square plus 2ab plus b square. Okay, so similarly a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus
b cube.
Okay, so we can write the coefficients of this term. Okay, so here the coefficients are 1 and 1, right?
Yeah.
Okay, so here the coefficients are 1, 2
And
1. Okay, so then here the coefficients are 1, 3, 3 and 1. Okay, like this, these are the coefficients. Okay. Okay. So what you can observe here, the power of A is decreasing. A square is becoming A, whereas power of B is increasing. Same thing here. Power of A, 3 has become 2 here, 2 has become A, whereas B power, B has become B square, this has become. So one is decreasing, other one is increasing. Okay. And in each term of the expansion, the sum of the indices of B is the same and is equal to A plus B. Okay. In each of the expansion, the sum of the indices of A and B is same. So indices
when you add,
so
it will be equal to n.
In each of the expansion, the sum of the indices is same and is equal to A is equal to index of A plus B. Okay. So you can see the index of A plus B is 2 here, and here index the sum of the indexes is 2 here. Sum of the index is 2 here, sum of the index is 2 here.
Yeah.
So the sum of the indices are same. That is another important thing. Okay. So here you can see A and B have indices 1, 1 plus. So the sum of the indices are same. We now arrange the coefficient in this manner. So a plus b to the power 0, you can arrange the coefficients like it will form a triangle called Pascal triangle. So this is 1, 1. Okay. Then this will be 1, 2 and 1, 2 and 1. Okay. So like that, then this will become 1, 3,
3,
and 3,
3, and then
okay,
1.
and then 1, 1, 3, 3, 1, 3, 3, okay, then 1, okay, like that. So this will become 1, okay, then 4, okay, then 6, okay, then 4, okay, then 1, like that. These are the coefficients. So this is so do you observe any pattern in the table that will help? Okay, so okay, so we can see that addition of ones in row 1 of index 1 gives rise to 2 in row 2 of index 2 addition. Okay, so okay, so this is just this is otherwise called as Pascal's triangle. Okay, uh, so without getting into the much details, what we can do is we will not get into the details of derivation at this stage. Finally, what will be the like take a
Binomial.
picture. We will go to the governing equation of a binomial theorem. Quickly, we will go through that. Okay, this is just I am telling what are the properties, like the sum of indices on the left side and right side are same,
Yeah.
and the coefficients forms a triangle like this. Okay,
Yeah.
so uh, so the final equation for binomial theorem is the final generalized equation of a binomial theorem is like nc0 a to the power n plus nc1 nc1 a to the power n minus 1 into b. Okay, then it will go on decreasing. Okay, so nc2 a to the power n minus 2 b square plus nc3 a to the power n minus 3 b cube. So what is your observation here? You can see
N
the n minus 1 is the indice here, b1 is the indice here. So total sum of indices is equal to 1. So in each term, sum of indices is equal to 1. This is n plus 0. So sum of indices is equal to n. Okay, so here n minus 3 plus 3. So the sum of indices is equal to n. So everywhere the sum of indices remains the same.
Yeah.
And another important thing is, like say, uh, this is NC0, it will go on increasing. It will become NC2. When this is 2, this n will reduce by 2. When this is 1, this n will reduce by 1. So this is the governing equation. Then the final term will be NCN. So it will go on and on. It will become NCN. Then a n to the power 0. Sorry, a n to the power n.
N. And
Okay.
B n to the
b to the power n. So the n has reduced and it has come to, from n it has reduced to 0. So a n has come down to a to the power 0.
So which is nothing but NCN
B0,
BN.
So a n has come down to a to the power 0 from the first to last term.
Where
Whereas
B, it was B to the power
0 has increased to b to the power n from first to last term. And the total indices everywhere.
It is NC0 A to the power n B to the power 0. First term, last term becomes NCN A to the power 0 B to the power n.
So if you remember this, what is my first term? NC0 A to the power n, NCN B to the power n. So then in between the terms will be NC1 A to the power n minus 1.
A power will keep on decreasing, B power will keep on increasing.
Very simple. This is very simple. The derivation will take little time. So the coefficient will same as what we are doing the Pascal's triangle. So NC0, then it will be first, second will be 1C1 and 1C0, 1C1. Okay. Then second one will be 2C0, 2C0. Okay. Then 2C1 and 2C2, right? Like that. So then this will be 3C0, 3 3C0, then 3C1, okay, then 3C2, then 3C3. So like this, these are all coefficient. These are arranged as Pascal's triangle. So this is the governing equation, and there can be n number of numerical uh, frame based on this understanding. Okay. So there can be n number. This is the fundamental principle. Okay, you can do n number of numericals based on this. Okay. Okay. Then okay, so they want you to, suppose they have asked you to find out, compute 98 to the power 5. Okay, compute 98 to the power 5. So you can use binomial theorem here, because it is not that easy to do it by hand or memory. So it will become 100 minus 2 to the power 5. Okay, so in this case we know our n is equal to 100 and
no, n is equal to 5, a is equal to 100.
Sorry, so n is equal to 5. Okay. So a is equal to 100,
b is equal to minus 2.
2.
Minus 2.
No, minus 2. Okay, a plus b. Okay, so b is equal to minus 2. Okay. So now you can put these things in this equation. Okay, so you will have 5 terms here, that you know. Okay, so it will become like, say, n. So n is 5, then it will be n C0. Okay, C combination of 5 C0. Okay, 5 C0, then 100 to the power n, right? 100 to the power 5 into b is anyway 0.
b to the power 0.
So it will be b to the power 0. So minus 2 to the power 0. Okay, then it will become 5 C1, then 100 to the power 4. Okay, then minus 2 to the power 1. Okay, then 5 C2, 100 to the power 3 minus 2 to the power 2. Okay, then 5 C3, 100 to the power, sorry, there is a problem here.
No.
100,
correct.
no. Is it okay?
Yeah, correct. 100 to the power 4,
Okay.
b to the power 3.
Okay. No. 0, 1, 2, 3, right?
100 to the power 3.
100 to the power 4, 3, 100 to the power 2 here. Okay.
Minus 2 to the power 3.
Minus 2 to the power 3. Okay. Then next term will be 5C4.
5C3. 5C4, sorry.
5C4, 100 to the power
1.
1 minus 2 to the power 4. Okay, so I have 1, 2, 3, 4, 5. Then another term will be.
You will get n plus 1 term.
We will get n plus 1
terms.
term.
In binomial, you will get n plus 1.
N plus 1 term. Because this, it starts from C0 to Cn. That means n plus 1 term. So we are 1, 2,
last
3, 4,
term
5.
is 5C5, 100 to the power 0.
5, 100
to the power 0 minus 2 to the power 5.
So this is how you solve a big square term, and a term other than the exponent other than 2, 3. How to deal with it? Like
you'll get n plus
big
1
number and the exponent is much high. In that case, you have to use binomial theorem. Okay. So this is such an important theorem. You can now see like what is the utility of this theorem. Okay. So this is my this term. So this whole things comes. So I have 1, term 2, term 3, term 4, term 5. There are 6 terms. So in a binomial equation, a plus b to the power n means you will have n plus 1 term. Okay. So there is a tricky question. So there can be which is larger. Okay. So 1.01 to the power 6 zeros. Okay. 1, 2, 3, 4, 5, 6, 6, 0. Whether this is larger or 10,000 is larger or 10,000. Okay. Question is which is larger? Larger. Okay. So this one looks the base looks to be very small. But if you solve it using binomial theorem, 1.01 you can split as 1 plus 0.1. Then if you solve, like it will become 1 plus 0.01 to the power let us
10
say,
per 6.
so if you solve it, the using that binomial equation, you will find the final term will be 1 plus 10,000. Okay, 10,000 plus some other positive term. So this is, that means it is
more
greater than
than
10,000. Okay, so that is the conclusion. So these are some of the tricky things in binomial theorem. Okay. So yeah, sometimes you can find out the middle term, how to find the middle term. So that is bit tricky. Okay, so that you have to find out how to find the middle term. All these things you have to practice. Okay. So you know that now what is the governing equation. Now it is your time to practice as many as possible.
Okay.
So we have covered permutation combination. We have covered binomial theorem. At least 2-3 questions will come. These are simple things. We should never leave out these things. Okay. Thank you.